Okay, so yeah, these are all the inverses. So tangent x is equal to 1 over cotangent x, and the same can be said if I write, if I draw circles that happens, but say I had cotx is equal to 1 over tangent x. Okay, so that's that same idea there. Same with this. This is the inverse in that. And these are the two rules she gave you. Sine squared theta, or x, plus cos squared x is equal to 1. And tangent x is equal to sine x divided by cos x. And these are always referring to the angles. Okay, these all refer to your angle, whatever the angle of the triangle is. Okay, so do you want to just go through the first question here? Is this what she's giving you? Okay, so the first question she dealt with, let's do this in black, is cosine x times cotangent x is equal to 1 over sine x minus sine x. Should record. So like I said, we're just this means this times this, so these are like one number, and this is the same idea, number and a number. When working with these, it's helpful to, essentially, you're going to work with either one side or the other. So I'm either going to work with the left side of the equation or the right side of the equation. Now from looking at this, if I look at the left side, I have two different trig identities of cos x and cotangent x. Well, on the right side, I'm only dealing with sine and sine. So what I may try to do is all I have to do is prove that one side is equal to the other. So I may just work with the left side here. And what I'm going to do is I'm going to try to change them all into sine x, so that I'm only working with that. So I'm going to change this cos x into a sine x somehow, and this cotangent into a sine x somehow. So I'm always working with sine x, okay? So that'll be our idea here. So let's see if we can't do that. So let's say we're going to work on the left side only, okay? Now if we go through our rules, there's nothing here that puts us right to sine x, okay? In fact, we run into an issue with cos x. The only rule we have is it's equal to 1 over secant x, okay? So there we're running into some issues. But here we also have tangent and sine with our cos, okay? So what I can actually do is I can rearrange this identity here to be equal to cos. And what I would do in that sense is I'd bring the cos x to this side, right? In order to do that, I have to multiply this top by cos x. Oh, I forgot that's going to happen. And this side by cos x. You want me to write that out for you?
What do you mean?
So let's say, no, we'll do it at the bottom. So very first step, let's say, is what I want to do is I want to turn this cos x here into something that has a sign in it, at least, right? And we know this rule on the side. I'm going to rewrite it again. Tangent x equals sine x over cos x, okay? Now what all I have to do is technically this rule is not just telling me what tan is equal to. I can figure out what sine is equal to, or I can figure out what cos x is equal to. I can just rearrange the equation to set it equal to that, just like any other algebra, right? So in this case, I want to set this equal to cos x. So I would normally bring this to this side, so then I'd be left with cos x times tangent x excuse me, is equal to sine x, okay? And then I can bring the tangent over here. So I'll actually draw that out for you here. So what I'm saying is the next step will look like this. Cos x times tangent x equals sine x. Does that make sense? What I did is I just brought this cos x over to this side, because this is divided by. So in order to move it, I have to turn it into a multiplication. So I have cos x times tan x. And when I multiply this side by cos x, the top one and the bottom one cancel out. That makes sense? So I only have sine x on one side. I have times cos x, or cos x times tangent x.
You're allowed to move it onto the other side.
It's an algebraic expression. I can move it around all I want as long as I follow the rules of math.
Oh.
Okay? So this says, right now, I know it's kind of smudged, but that says, this is telling me what sine x is equal to right now. So I've already made a second identity out of the first one. I've made another one that says sine x is equal to cos x times tangent x. Okay? And finally, I need to set it equal to cos x, because I want one that says that. I just got to bring the tan x to the other side. I'd have to divide by it. So I'd end up with cos x is equal to sine x divided by tangent x. I'm just going to clarify this one here, though, because I know it's kind of squished. This one says sine x is equal to tangent x times cos x. Okay? So all I did is I moved between, I started at this one here, tangent x is equal to sine divided by cos. I rearranged it. So in the next one, I set it equal to sine, so I just moved the cos over. And then after I set it equal to sine, in the next one, I wanted to set it equal to cos. So see how we have cos here? I just moved the tangent over to this side, and then it was set equal to cos. Cos was equal to sine divided by tangent x, which is exactly what I have here. So I just rearranged the equation 3 times. Is that confusing? I want you to try it.
The teacher never did.
So the whole idea here now is I technically got 3 rules. They're all coming from the one rule. All they did was give me one rule, but I can make new rules from that rule. That's what I was telling you, Trig Identities. Yeah. So yeah, exactly. So now, because look in this question, right? We're dealing with cos and cotangent, and my idea was, well, since these are both sine, I'm going to try to change this side to sine x's, maybe. Okay. Well, if I looked at my rules, this rule had nothing for cos x equals. I don't know what to replace this cos x with. So I rearranged the equation to set it equal to cos x. So now I can substitute this in for my cos x. So now I have a sine at least in there. Does that make sense? Okay. So the whole point of all this is now I'm going to replace my cos x, because we have it here, with sine x divided by tangent x. Okay?
But don't you have to
Times.
Can't you not have tan?
Yeah, well, what I can't do is I can't just replace cos x with sine x. So what I'm trying to do is I'm trying to get a sine in there, and then I'm going to see if I can maybe cancel out this tangent somewhere. Okay? So here's the idea now. I know that cotangent, and I put ls because that means I'm only dealing with the left side, so I don't have to continuously write out the right side. I'm only working with my left side right now, so I'm going to put equals. Okay? So this is my left side. I replaced my cos x with sine x divided by tangent x. Okay? So now I have a sine. Now I have cotangent. Okay, well, there's a couple steps I can do here, right? I can look up here at my inverse, cotangent, and if I rearrange this equation, just like we'd arrange the other one, I know that cotangent x is equal to 1 over tan x. Does that make sense? You've seen that before? So I can replace this cotangent x with that. I can flip that all around. So let's try replacing it and see if it helps. The whole idea is to continuously replace things and see if I can manipulate it more, cancel things out, or essentially I'm trying to almost paint a picture of the right side. So now we're going to replace our cotangent x with 1 over tan x. Does this make sense so far? Okay, so now I've replaced that. Well, according to my right side, if I were to multiply these fractions, I'd have sine x over tan squared x. But looking at my rules, I have no idea what a tan squared is going to be, so I don't really want to go down that route. It's not good.
Can you divide them?
I could, well, the question says these are think of these as 2 fractions. This is a fraction, and this is a fraction, right? When I multiply fractions, I do the top by the top and bottom by the bottom.
Then couldn't you switch it to make?
Well, what I'm going to try now maybe is why don't I could replace my tangent x with something. We know that tangent x is equal to sine over cos. I could try replacing it with that stuff.
Both of them?
For both of them, yeah, we could, and we'll end up with more division. We'll end up with sines and coses. It could get quite complicated. Let's see if that helps us, okay? So we figured out that we can replace our tangents, right? So let's do them one at a time. I'm going to do the one on the right first. It's always good to do one step at a time because sometimes you miss things. So I'm going to replace the tangent, x on the bottom, with sine over cos. And then you know that because it's 1 divided by sine over cos, what's going to happen is going to have cos x divided by sine x. That's the equivalent, okay? So we take a look at these. It actually isn't really taking me in a route that's majorly helpful. If I look at this, here's something I know I can do, okay? I know that if I multiply these fractions, this and this are going to cancel out. So I'm going to be left with cos divided by tangent. I'll be left with cos divided by tangent, which really isn't my right side right now. It's leaving me at a funny root. Okay, so let's look at this, just to help us a little. So, like I said, our sine x's are going to cancel out, and I multiplied across, right? So I'm left with cos over tan. Does that make sense? Mm-hmm. I did this in a roundabout way. If I look at this, what I could have done is I know cotangent is essentially 1 over tan. So all I am right now is here. I multiplied that by that, right? So I did this in a really roundabout way, which, like I was trying to tell you, is there's many ways to go about doing things. We tried it this way because we were hoping to get more sine x's into it. But what we found out is we ended up eliminating our sine x. So now I have cos x divided by tangent x. So let's look at our identities here. Cos divided by tangent. If I were to replace cos and tan, I don't really seem to get anywhere. Okay, well, I don't seem to get anywhere with that. What I can try to do instead.
And then add them together.
So, the easiest way to get it, looks like it was the answer from when we looked at it. If we just replaced cotangent with cos divided by sine, is that what it is?
Yeah.
Yeah. So let's scroll to the bottom. Let's redo this, because we went in a convoluted way. And that's the problem with this. There's many different ways to go about it, so you're not really sure the root. If I just replaced cotangent with cos x divided by sine x, again, we're still working with the left side, right? I would have been left with cos squared x over sine x. Don't forget this x. And then you remembered the rule that cos squared x is equal to 1 subtract sine x, sine squared x, sorry, over sine. Okay? So now, here's the tricky part. So this is the tricky part here, okay? What happens here is essentially can be two different questions. This can say 1 divided by sine, subtract sine squared x divided by sine. Let's not forget the x.
Can that be a difference of squares? Like 1 plus sine x squared?
Yeah, if you find the square root of the first one, you would 1 plus
and then 1 minus
sine squared times 1 minus sine squared x. Yeah, you can do a difference of squares, but we don't actually really need to. Okay. It's going a little far. But you're right, yeah, that is a possibility because that is a difference of squares. Think of this as two separate questions. So what this really says now is 1 divided by sine x, subtracted by sine squared x divided by sine x.
Oh, and then you just
okay?
take it.
It's like reverse subtraction with fractions. Normally when we subtract fractions, our answer, what we're trying to do is simplifying. We're expanding this. Normally we try to get the bottom to be just sine, right? Mm-hmm. So yeah, so now I think you see it, right? So now I'm left with 1 over sine x, and then sine squared x divided by sine x is just going to leave us with sine x. Does that make sense? Yeah. So, there was really no reason to do it the way we did in the first place. But like I said, sometimes you can't see the answer so simply, right? You go about it, and there's a million different ways. So sometimes you might get as far as we did here, and it's like, you know what, that was of no help, so let's try a different route from where we were. Sometimes it even helps just going to the other side of the equation. Okay, so this is the second example. Let's see what we can do with this. We know that this here is the same as sine squared, right? So let's replace that with it. This is the same as sine squared x is equal to cos squared x. Now, what I want to figure out here is, what is this going to be equal to? I could technically distribute this onto both of them. Okay? But then, right?
Change them first.
I could change this, but the question is, what can I change this into?
To sine. Whatever.
Well, what is cosecant squared x going to be equal to? 1 over sine.
Squared.
Okay, so you move the cosecant squared x. You decide to change it into 1 over sine x, right? Sorry, squared. Make sure you keep that squared.
Yeah.
Subtract 1, all in brackets. Sine x squared. So we're going to work with the left side, okay? Well, I guess I'll keep writing this. Then we distributed the sine. We multiplied it by this, and we multiplied it by that. So in this case, we ended up with sine squared x over sine squared x minus, sine squared x. This is not the root you took, is it? It's fine.
I just found an
Oh.
LCD.
The reason this is fine is, what is sine squared x divided by sine squared x? 1, right? So this says 1 subtract sine squared x is equal to cos squared x, right? And we know that's right from our identity.
That's close. That's the exact same thing I said.
Yeah, we know from looking at our identity, if I move sine to the other side, it'd be 1 subtract sine squared x, right?
Mm-hmm.
So obviously we'd have to prove it another step. In this one, we'd have to say 1 sine squared x is equal to cos squared x is equal to cos. This is technically what you're trying to find. This sine is equal to that sine. Okay? Does that make sense?
Mm-hmm.
All right, so we went about that. Okay, let's deal with this question. State the exact value, no decimals. So it says cos 315. Okay. Do you know the CAS system?
Yes.
Okay. So let's, I'm going to do it in blue, okay, down here. So we have CAST. And you realize what that means? Everything's positive in the first quadrant. And do you know the numbers? Sorry, 1, 2, 3, and 4. Okay? So here we are. A means everything's positive in the first quadrant. Sine's positive, tangent, cotangent. Okay? We're going to work with... I wish I could rotate that, but I guess I really can't. We're going to start here, okay? So let's say that this is where we are, and we have a line. This line is 1 centimeter long, or whatever it is. Okay? It says we need to go 315 degrees. Well, I know if I turn the line up to here, I've gone 90 degrees, right? If I pull it all the way down here, I've gone 180. If I bring it around to here, so essentially this is what I'm saying. Yeah, if I've come around to here, I'm at 270 degrees. And if I go all the way around, I'm at 360, okay? So obviously that's not how far I want to go. What I have to figure out, what is the difference between 360 and 315? So 360 subtract 315, yeah, 45 degrees. So in other words, this is what they're saying here, is they want us to create a triangle, okay? And this is what happened. Here's our line. We know the line is 1, whatever it is long, okay? And I know that the difference here, this corner here, is 45 degrees. So I'm going to get rid of this other stuff I've drawn a little. This is the hardest part. Do you understand that I've now drawn a triangle where this angle is 45 degrees?
Yeah.
Okay. So this distance is my 1, we say. Okay. But essentially, this is our radius. This is our x, and this is our y. So what are the specialties of a 45-degree special triangle? I know this angle is 45. This one is 90. And what's the other one? 45. Okay. And what are the measurements? Or in other words, what's the ratio of this triangle? Do you remember what they are?
We have a chart.
Okay. Take a chart out.
I know that.
Do you have it with you?
Well, she just told us to memorize it. I just have to write it down. So.
Now's a good time.
Sine and cos and tan and 0.
Okay, so you made this chart. That was a pretty neat chart, actually. I haven't seen that before. That's a way to memorize. You did sine, close and tangent. And we want to know what they are at 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And what do you got? You got 0, 1, 0. You got a half, the root of 3 over 2, and then 1 over the root of 3, 1 over the root of 2, 1 over the root of 2. Yeah, those will be the same. 1, root 3, a half, root 3 over 2, and finally 1, 0, 1.
0, 1, 0. 0, 1 undefined.
0, 1, yeah. This should be 1, 0.
Oh yeah, 1,
undefined.
0, 1.
Yeah. Undefined. Okay. What you need to realize is essentially what they're doing is they're referring to this triangle here, all these measurements. Okay.
She showed us how to write it out, but she never showed us how to use it with the triangle.
Think of it like sine. If you remember your old rules, a sine is equal to what? Opposite over hypotenuse, right? Yeah. So let's say that this is our sine, right? Oh, sorry. Yeah. So here's our line. Okay. So we're looking for the opposite angle. Sorry. This is our angle here. We're dealing with this angle, which is our 45 degrees. I don't know why you chose it on. Here's our 45 degree, right? We need the opposite side, which would be here, and the hypotenuse. Okay? So opposite side and the hypotenuse here. If you look at a special triangle, one of the ratios is you have 1 and 1, and then root 2. Okay? So if this is my angle, my opposite and my hypotenuse, well, this becomes sine is equal to 1 over root 2. So there's our 1 over root 2 for 45 degrees. The only special part here, though, is this was at 315, right? And, I'm sorry, we're dealing with cos. Yeah, sorry, you're right. It is the same with cos. The only difference is, in this quadrant, would sine have been a positive answer? No. Is cos a positive answer? Yes. So we're in that quadrant, so cos is a positive answer. So our answer is 315 is essentially equal to 1 over root 2. Positive, because cos is positive. If they'd asked me for sine 315, it would have been negative 1 over root 2. Does that make sense? So that's the whole idea with tying it into the triangle. Okay? Okay, so we got, let's say it's a stop sign. Okay? So we have some sign, and it's across the road from us. And we have our dude standing here, Frank, right? So from this spot, here's the base of the sign, and to the top of the sign, get another. So it'll be a little easier if this is on a sideways angle, I guess, right? Here's our sign. Frank wants to know how we know the angle of elevation is 19. So this is 19 degrees from where he's standing. Okay. He then decides to walk all the way over here, which is 20 meters away. And then he observes that a new triangle, which is on the ground, the angle between the base and his old spot is 52. So in other words, this is 52 degrees. So our next triangle, let's say, here's another spot. This is 52 degrees, and this is 20 meters. And again, we have this. So we have two right angle triangles, you could say. That's supposed to be thought like this. Can you see the 3D triangle? Mm-hmm. Okay. So we have a measurement, an angle. They want the height of this side. So in other words, we need to get one of the measurements in this triangle over here. This triangle over here, we need either this measurement, or even this measurement, but we're probably going to end up with one of these two. Looks like we're going to end up with this measurement here, because we have this angle, and we have the distance of this side of the triangle, okay? Now, The only thing is we need one more piece of information in these
Get
triangles.
the angle beside the 19.
Yeah, to get the angle, or sorry, the distance beside the 19. Now we could figure out this angle here, okay? And then we'd have all the angles in this triangle, but that we're using SOHCAHTOA because this is a right angle triangle. While in this one we're going to be using cosine or sine law. In order to set up sine law, we need this distance here. We'd have to know what this is, because then we'd have this measurement. Or we need to know at least what the other, sorry, not distance, what angle this is at. Or we'd have to at least know one more angle in this in order to figure out our